The convergence of preventative maintenance on industrial equipment, on automobiles, whatever it might be, predictive preventative maintenance, combined with the growth of Industry 4.0, Internet Things, I think makes this company a really unique opportunity. So without any further ado, I would like to introduce CEO and founder of the company, Daryl Dominique.
Thank you. You're driving north down the Highway 400, and you feel your truck lurch slightly. Nothing absurd, really. These are Northern Ontario highways after all. 2 kilometers later, though, you realize that you've lost an entire set of wheels. And backtracking, you find that that same set of wheels has completely crushed an oncoming SUV. Now, the quick investigation shows the cause. Lug bolts sheared clean off. Now, this story occurred in January of this year, and somehow on Ontario highways from 2010 to 2015, there have been almost 600 cases of wheels separating due to lug bolts failing. How is it that we live in the age of modern technology, but we find ourselves seemingly limited by the basic nut and bolt that we use in almost everything we produce, whether it be vehicles, mining equipment, or industrial machinery? My name is Daryl Dominique, and I'm here to pitch you my company, Hexic Monitoring Systems. I'm a mechanical engineering graduate from Laurentian University. I spent my last 3 years running a product development and prototyping company working within the startup community, and I have experience in vibration analysis. And it was these 3 factors that led me to take on a professional experiment some 12 months ago. There were a group of folks complaining about having to pause production on their rock chute in order to send someone down with an ultrasonic device, manually inspecting every single bolt along the entire length of the chute. I thought to myself, well, that can be automated, and so began a series of failed experiments in trying to create a low-cost sensor to achieve just that. Eventually, though, I remembered the sort of information one could gather from just looking at a vibrations waveform, and I made that the focus of my efforts. So here we are, a little less than 1 year later, with Hexic Monitoring Systems. We're an early startup company composed entirely of a team of, so far, just myself, working with Norton Rose Fulbright towards our provisional patent. Because simply put, we've successfully developed a prototype that can identify when a bolt is failing from under or over tightening and general wear and tear. Not only that, but the sensor that we're using is extremely low cost and should function on any mechanical system that is exposed to vibrations or impacts. So let me explain what that means. What you see here is a diagram of 3 Hexic sensors in place on the wheel of a car that's just hit a Sudbury pothole. So we can note that the first 2 waveforms, the green ones, are near identical. We can also note that the third waveform, the red one, is showing some clear discrepancies. Now, these discrepancies are consistent with a nut and bolt fastener that's coming loose. Similarly, an over-tightened nut and bolt fastener that's approaching a shear point will show identifiable discrepancies, admittedly significantly more subtle. So by comparing the data from a number of these sensors, we're able to highlight and diagnose a problem before it ever becomes a catastrophic event. So let's take a closer look at the sensors themselves. This image shows the concept of the next generation of Hexic sensors. These are designed to function with existing machines and with the existing tools for those machines by simply replacing the currently existing hex nut with one of our own. They're slightly larger around the base, ensuring we don't compromise any of the mechanical properties, but they provide the sensor data that we need in order for our system to function. These sensors then interface to a simple control unit, which does the processing, the analysis, and provides the connectivity for the end user to be able to get their alerts, updates, and any notifications of events that this thing is detecting. So the Hexic system is composed of a number of low-cost sensors, a single control unit, and associated software, mimicking the structure of today's Internet of Things, or IoT, products. So let's take a look at those numbers. Well, the industrial IoT industry is set to generate almost $300 billion in annual revenue come 2020. And now, while I use the automotive as an easy example for simple to visualize, I think we're going to need a few strong cases before we approach them. So I think our actual early adopter market is going to be the mining and heavy industries, largely in part due to the fact that we're located here in Sudbury. So if we make that the area of our focus, we find that in 2012, Canada spent $43 billion on heavy machinery and equipment. And that gives us a pretty good idea of the assets that we're looking to protect with our sensor. Not only that, but it makes good financial sense to protect these assets as well, given that an estimate by the Gates Corporation came up with $180,000 in lost profits for a mining company per incident. Now, one thing to note here, that's per incident, not total losses per year, but per individual incident. And in a fleet of several hundred pieces of equipment or several hundred vehicles, you're looking at a significant number of those incidents. Just imagine what we could save by preventing even some of those incidents. So how are we going to do this and why Sudbury? Well, thankfully, Sudbury gives us a couple different opportunities that may be significantly more difficult to find elsewhere. First and foremost, there's the Fortin Discovery Lab. This is a local product development facility, something that we can use to create the next few generations of the Hexic sensor. Not only that, but the Fortin Discovery Lab also houses some of the certification equipment required to ensure that our sensors meet legal standards, something we'll definitely need to do before we put them on shelves, and something that's usually a huge time and money sink during product development. On top of that, NORCAT, our hosts for tonight, are also the proud owners of a product development and testing mine. This is a small operating mine that serves as a location that we can put our products in long before we'll be able to do so on a larger mine. And the benefits that this gives us cannot be overstated. We can use this as a way of gathering the kind of data we need to further improve and refine our algorithm, ensuring that the reliability and accuracy of the product that we're offering truly ensures that our product is the solution to this problem. So correspondingly, here's our target timeline. Now, it's ambitious, I fully admit that, but these are the goals that I'll be aiming to hit from the moment this event is over. Priority 1 is development of a minimum viable product based on our currently existing alpha prototypes. From there, we'll put those in the NORCAT testing mine to start commencing on that data analysis and that data collection, ensuring that our algorithm is being improved as we go. Simultaneously, we'll begin work on the software for Hexic Monitoring Systems, eventually wrapping up everything together into our first implementation and our first sales-ready product. So here's the revenue model that we're originally going to be pursuing with Hexic. It's a simple service and subscription model. Essentially, companies will be paying an annual fee for the sensors and the control units, and this should be a pretty easy sell given that there's very little worry for them. Hexic is handling everything, and they're just getting the data, insights, and analytics that they need. So let's build some representative customers who would take part in this. We're going to have to make some assumptions here. So let's assume a small company has a fleet of 30 pieces of equipment, a medium-sized customer has a fleet of 60, and large is up to 100. Now, for the sake of a simple, easy mental image, let's say all of those pieces of equipment are scoops. Rock chutes and conveyors are more ideal, but scoops give us some nice numbers to work with. So we have 25 lug bolts per wheel, let's say, 4 wheels per scoop. That gives us 100 sensors per scoop. So then we can start laying out some basic subscription rates. Let's use some low, easy numbers, something that's really easy for those early clients to digest, something that should really attract them. Let's use $8 per sensor per year and $25 per control unit per month, and extrapolate that, assuming only 3 small clients in our first year, and see where it takes us. Now, the individuals who are advising me on my financial forecast here may laugh because the discussion of how we were going to approach this got rather difficult. But eventually we decided on a conservative approach, assuming that we only focus on the scoops and we only focus on the wheels of those scoops, ignoring other machines and ignoring any other aspects of the one machine. And this is what it gives us. So our first year goes into the negatives, obviously, as we turn our prototypes into products and develop that end-user software. From there, though, even with just 3 small clients, our first year starts sustaining itself and even turning a small amount of profit. And then into year 3 and 4, we can really see the effect of those small subscription fees, those really easy to digest numbers, as they start accumulating at an extremely healthy rate. And again, this isn't even considering other equipment or other machines, and it's also not considering my favorite part of Hexic. And that's our final revenue model. That's the revenue model that I think is going to be most important. And that's a licensing model. So once we have those first few clients, once we have the data to prove that our sensor is functioning in the real world, then we can start trying to license our technology to companies like Tesla or Ford or Caterpillar, trying to get these included as an added default safety feature. Much in the way things like the modern-day tire pressure sensor is included in even the most basic consumer vehicles. It's with this model that we can expand into the automotive industry, aerospace industry, watercraft, and, like I said, potentially anything that is subject to vibrations or impacts. So Hexic is seeking $200,000 in strategic angel investment to accomplish the following goals. Priority 1, as said, we need to develop a minimum viable product based on our alpha prototypes and the accompanying software. We also need to get these things inside the NORCAT test mine to start really running on that refinement of the algorithm. 3 are those marketing, trying to get those at least 3 early adopter clients, and if more come, fantastic, but that's going to be a crucial aspect. And 4, further improving our intellectual property. We're working with Norton Rose Fulbright, but intellectual property is going to be an incredibly important part when we reach the licensing model, and we may need some help getting there. So I certainly hope we can get involved, some of you in this company, as I believe your expertise and your experience could be an incredible asset to what I hope to one day call our company, and I hope I get to speak with you later in the evening. Thank you so much for your time, and I'll remain on stage to answer any questions.